Let's just check if the recording has started. Great. Everything seems in place. Good morning, good afternoon, and good evening to everyone. Welcome to the final session of the Industrial Ecology Day 2024. In this session, we will explore the current research and future perspective on circular economy in Latin America and the Caribbean. My name is Glenn Aguilar, and I will be the moderator of this session. This session was organized as a collaboration between the UNICA project from Leiden University, the School of Management from Universidad de los Andes, and the Peruvian LCA and Industrial Ecology Network from Pontificia Universidad Católica del Perú. This session will last about, it's a 1 hour session in which we will have 3 main components. In the first part, we will have 3 short presentations by our guest speakers. The second part will be a panel discussion where all the audience is welcome to bring their questions and comments to the speakers. And we will close with some final remarks. Please keep in mind that we are recording this session. You are welcome to provide any comments or questions at the designated time by raising your virtual hand that is up on the top of the bar or via the chat box. I will be grateful if you can keep also your microphones turned off while the speakers are presenting. Also, to check the chat box, we have created a small survey that we would like you to complete right now, if it's possible. So if you go into the chat, you can see the small survey and just tell us from which country you are joining us today. Now, let's begin with our presentations. Good, let's begin with our presentations. It is my pleasure to introduce Pamela Sanabria-Cuervo. Pamela holds a Bachelor of Business Administration from the Universidad de los Andes and a master's degree in Interdisciplinary Studies in Sustainability from Universidad Autónoma de Barcelona. Pamela has a broad experience in consultancy, research, and project management related to topics such as sustainability, circular economy, and SDGs. Currently, Pamela is focused her research on circular economy finances. Pamela, thank you for being here with us, and I would like to give you the opportunity to start your talk right now. Welcome.
Thank you, Glenn. Thank you for the introduction, and thank you for the space. I will then start sharing my screen. If you can confirm me if you can look at my screen now.
Yeah,
it's okay?
All good. All good. Perfect.
Perfect. So once again, thank you very much for this space and for the introduction. As Glenn mentioned, I'm Pamela Sanabria, and today I'm going to present about a paper I'm working on with Professor Bart van Hoof. He's an associated professor at Universidad de los Andes in Colombia. And our research title, which I'm going to talk about today, is called Metabolism Practice for Decision Making in Public Policy Process in Latin America and the Caribbean. So just to give you a small background of our research, as part of our review, we explored the intersection between national public policy making and the transition towards circularity. So shaping national policies for circularity, we know, is a complex process influenced by the interplay of multiple actors, but also multiple political interests that are in the involvement of the diversity of the stakeholders. So these stakeholders can include government agencies, private sector entities, civil society organizations, and each one of those contribute with different perspective, resources, objectives. Each one of it has a different point of view. So one of the main challenges in this context is to integrate those diverse public interests and also competencies. So policymaking requires perhaps a framework that incorporates these various points of view and aligns them into coherent strategies that are aimed to this circular transition. So also as part of this research, we reviewed the material flow analysis as a tool for decision making in circular economy. So this tool, by analyzing the flow of resources and materials within the system, helps identifying those inefficiencies and potential areas of intervention, offering a more systematic approach to integrating the metabolism analysis into policy process. So, however, what we look at in this review is that most material flow analysis have been conducted more in an academic scenario, in academic settings, and they not necessarily have been adopted by stakeholders in the public policy making. So what we propose with this background in this research is to explore material flow analysis as a tool for integrating those multiple public policy interests that we talked about, and those competencies from a decision-making point of view in the public policy process. So in this context, what we basically propose is, we propose is merging two theoretical fields as a way to create an interdisciplinary approach for the governance for circular economy. So in one hand, we look at the public policy decision making, drawing insights from social theory and agency. And here in the research, we found existing research that addressed the challenges of contemporary public policy making related to what I said in the background, the diverse governance structures that are involved, that involve that variety of factors, and the agency approach as a mechanism for navigating structural challenges, focusing on perhaps how individuals and organizations can drive that change despite those like systemic obstacles or challenges. So in this specific field, we found a gap in the tools and models proposed to address those challenges in the collective public governance. And then on the other side, we look at the socioeconomic metabolism between the biophysical science. So we focusing on specifically on the material flow analysis. So from this perspective, research has looked at material flow analysis as a decision-making tool. We have seen works in resource, waste management, and we also identify some examples of a national material flow analysis implementations, studies in perhaps China and some European countries. However, our review in the Latin American context, we found limited work on the implementation of the material flow analysis for decision making in this context. So what we try to do with this research is bridging these fields of together of public policy decision making and socioeconomic metabolism to address those gaps in governance tools and in the use of material flow analysis for, in this specific case, national public policy in the context of the region. So this is the context for our research question that's focused on how to use material flow analysis decision-making in public policy, in decision-making in public policy process. And here, I think it's important to clarify that public policy making involves like a variety of elements, let's say perhaps steps, but in these questions, in this research question, in this study, we aim to explore how material flow analysis can serve as a tool specifically for priority setting in the public policy. So by looking at this, we seek to understand how MFA can help policymakers to identify those key areas that need intervention and that are aligned with that national perspective for circular transition. So with this in mind, I wanted to show you this diagram that perhaps summarizes our framework of analysis. So we focus on the construction of the material flow analysis, which involve, especially in the region, integrating that data that is managed by different institutions that use different data diverse systems. And to achieve this integration for building that material flow analysis, organizations need to engage in dialogue and collaborate one another. So ultimately, this interaction leads to an interdisciplinary public policy process for priority setting, especially related to advancing in that circular economy. So to say in other words, let's say the barriers of the implementation of material flow analysis help to create that interdisciplinary process for priority setting in the public policy. That's like our framework of analysis. And we operationalize these frameworks by aligning, let's say, the agency mechanism to address public policy challenges with the characteristics of material flow analysis. So we look at some authors here, which provide different agency mechanisms. And here we have brokerage, entrepreneurship, and leadership. And we use this as our analytical lens to link that public policy process with those challenges with the metabolism analysis characteristics. I'm gonna go through this a little bit faster because I'm seeing we are running out of time. But basically, in our research, we applied this framework to two cases of studies. That is the construction of the national strategy for circular economy for Colombia and for Uruguay. And these both strategies involve government institutions, civil society, external facilitators as stakeholders in the participatory process for building the national strategies. So basically, the construction of these strategies were selected because the construction followed a specific path that started with data collection for material flow analysis, then continue with the construction of the economy-wide metabolism with the tool, and then finalizing the national public policy priority setting in every step involving training to stakeholders to build capacity around the tools, but also validation with the stakeholders that created that dialogue and participatory process for the building. And just to highlight some results, both cases led to the result of the publication of the national strategies and to the priority setting linked to that material flow analysis. Perhaps here is a little bit smaller, but you can see priority setting are different in both cases, and in both cases are related with the result of the material flow analysis, but also in the building of the analysis itself. I'm gonna pass this real quick. That is our result showed in the linking to those agency approaches we saw. And just to finalize, in let's say our conclusion of our research, analyze the role of the material flow analysis as a tool for overcoming the public policy agency challenges. So by integrating material flow analysis in policymaking process, the results show that material flow analysis building process is a tool to address those complexities of aligning diverse interests. And here, just to highlight something else before finalizing, is how our research highlight the importance of merging these fields to address the public policy challenges in the circular transition context. Thank you very much. I hope I didn't take too much time.
No, that's perfect, Pamela. Thank you so much. So I will give you some claps, and hopefully you will receive some virtual claps as well over here. Yeah, there we go. Thank you so much. Thank you for such an interesting presentation. Now let's move on to the second presentation in order to be able to have. I think that you can bring your questions. The audience can bring the questions to Pamela during the discussion session. So let's move on to the second presentation. And right now, it is a pleasure. It is my pleasure to introduce the second speaker, André Torre. André is a doctoral researcher at the Peruvian LCA and Industrial Ecology Network from the Pontificia Universidad Católica del Perú. André is a civil engineer by training, and he holds 2 master's degrees, one in hydraulic engineering and environment, as well as one in business and product management. André will tell us about his work on circular economy and waste treatment in Latin America. So, André, thank you for joining us today and sharing your research with us. The floor is yours.
Good afternoon. Thank you, Glenn, for the nice presentation. Can you see my screen?
I will tell you, it's loading. It's getting there.
I'm not sure.
We can see your presentation. Yeah.
Okay. Well, good afternoon to everyone. My name is André Torre, and I'm pleased to present our research titled Multi-Criteria Decision Framework for Circular Wastewater System in Emerging Megacities of the Global South. This study was developed in collaboration with Ian Vázquez-Rowe, Ramzy Kahhat, and Eduardo Parodi. We took the megacity of Lima in Peru as a case of study, considering its critical challenge in water management. In fact, Lima ranks among the top 20 capital cities in the world with the highest water stress. With a current water deficit that runs to 3 cubic meters per second. Actually, the real deficit is even higher, considering that 800,000 people lack access to drinking water services. Additionally, water losses in pipelines reach 5 cubic meters per second, which is approximately 150% of the current deficit. To worsen the situation, the water system of Lima is highly centralized and highly exposed to natural hazards. In recent years, water supply has been disrupted by natural hazards like ENSO or El Niño solar oscillation. Finally, Lima is the second driest capital city in the world, with an average annual precipitation of only 10 millimeters. We propose a semi-centralized wastewater system at the district level to improve the performance of the current mega-centralized approach. The business-as-usual wastewater cycle focuses only on preliminary treatment, but our system includes secondary and tertiary treatment. This current system lacks resource recovery, whereas our proposal enables indirect potable water use. Finally, our proposal improves resilience and redundancy, thus scaling the probability of total system failure. We also craft 2 scenarios. For scenario A, focus on reducing eutrophication. We compare a group of biological treatment alternatives. These include variants of conventional activated sludge, as well as membrane bioreactors. For scenario B, designed for indirect potable reuse, we incorporated advanced processes like reverse osmosis and advanced oxidation processes, ensuring higher water quality standards in the effluent. Our methodological framework integrates multiple tools to assess wastewater treatment alternatives. First, we use the SAS software to design wastewater treatment plants, tailoring them to site-specific parameters. Then, we apply life cycle assessment to evaluate environmental impacts such as global warming and eutrophication. We also use life cycle costing to assess the economic performance of the alternatives. And finally, we apply multi-criteria decision analysis to integrate environmental, economic, and social criteria, enabling us to weight and compare the performance of different treatment trains. For the decision making, we consider environmental, economic, and social and techno-operational criteria, as I mentioned before. It is worth noting that we include criteria that might not typically be considered in technology selection in the global north, such as technological establishment. This criterion is particularly relevant for wastewater treatment plants in the global south, where delayed technological transfer and limited know-how often poses significant challenges. Regarding the results, for scenario A, we achieve a global warming impacts that range between 0 to 0.23 to 0.27 kilograms of carbon dioxide. In this scenario, the modified 𝐒𝐬𝐬𝐿 outperforms membrane bioreactors given the lower energy demand. The gap between gas systems and MBR was reduced because of the somewhat low carbon energy metrics of Peru, which relies mainly on hydropower. We also observe that chemicals contributes to 64% of global warming for gas and 40% for MBRs, given that membrane bioreactors can remove suspended phosphorus by ultrafiltration. The global warming for the scenario B was higher, given the higher energy use and higher chemical use. Well, we identify some limitations. One of them was that Peru lack of a well-developed domestic chemical industry, so the traceability of these chemicals was complicated, and we had to use import chemicals, which increased the uncertainty analysis of the global warming. Regarding eutrophication, all treatment trains could achieve 88% of mitigation compared to business as usual. Effluent concentration corresponds for 95% of the total impact, while chemicals contribute only to 5%. Among the treatment alternatives, Bardem process achieved the best performance due to its pre- and post-anoxic zones, which can reduce greater than nitrogen. In scenario B, eutrophication mitigation reached greater than 98% through near complete removal of nutrients and COD. However, the key focus shift from eutrophication to global warming impacts, highlighting a trade-off between scenarios. Because in this case, the eutrophication was resolved. Regarding life cycle costing results, in a scenario A, we obtain a code range from 0.12 to 0.17, higher than the cost for the business as usual scenario. In this case, MBR showed the worst economic performance due to higher investment and membrane replacement costs. However, low Peruvian energy cost narrows the gap between CAS and MBR system, which is higher, or which was higher in other studies. Regarding scenario B, cost increased to approximately 0.4 euros per cubic meter, driven by or mainly due to reverse osmosis membranes and energy-intensive process. Finally, regarding multi-criteria decision analysis, for scenario A, we found that Bardemfo performed best when environmental and economic criteria are prioritized, given the lower energy and chemical demand. In contrast, hollow fiber membrane performed best when techno-operational and social criteria were prioritized. Given that ultrafiltration membrane can reduce in greater depth the pathogen concentrations. For scenario B, hollow fiber membrane plus reverse osmosis and advanced oxidation process stand out as the top performing system due to its smaller footprint, lower sludge production, and flexibility to critical conditions. And to sum up the presentation, I would like to present the main conclusion of the study. Well, all treatment trains in scenario A achieve at least 88% of eutrophication mitigation, comparing to the business as usual system, just aligning to the European regulatory framework. In this scenario, Bardemfo performed best for eutrophication mitigation. In scenario B, all the alternatives achieves greater than 98% for eutrophication, but incur higher cost given the mainly to reverse osmosis, and also in higher global warming impacts confer on higher energy and higher chemical demand. In this scenario, hollow fiber membrane perform best when indirect potable use is sought from the outset. And finally, integrating wastewater treatment plants into Lima's wastewater cycle promotes a circular economy and aligns with Sustainable Development Goal 6. Thank you very much.
Thank you, Andre. Thank you for such an interesting presentation. As you can see, there are already some reactions from the public, and well, right now, for the sake of time and keeping the discussion, I would say that let's continue with the last presentation of this session, and then I will like to invite all the audience to bring all your awesome questions to the speaker. So, well, thank you, Andre. Now, last but not least, it's my pleasure to introduce Diana Ita. Diana is an environmental engineering. Oh, sorry. Diana is an environmental engineer and holds a master's degree in industrial ecology from TU Delft and Leiden University from the Netherlands. Diana has a PhD in engineering from the Pontificia Universidad Católica del Perú, and her research focuses on environmental assessments of marine waste. For example, using methods that allow us to measure the amount of plastics that reach the coast from land-based sources. Diana, a great welcome, and the floor is yours.
Thank you. Thank you for the presentation. Thank you everyone for staying for my presentation as well. I'm just trying to do the sharing. Can you see my PowerPoint?
Yeah, we can see it now, Diana.
Perfect. Yeah, I'm not that.
And just right now we're looking into the speaker view. So if you can change it for us, now it's perfect.
Okay, perfect. Thank you. Yeah, I'm not that used to Teams. I use more Zoom. Well, hello everyone. Today I'm going to be talking about the project or the investigation, the research that we are doing here at PUCP at PELCAN. And this part is going to be centered in plastic pollution. And the idea is to understand how much plastic we are throwing right now into the ocean and how we can map and quantify marine plastics in the global south. Because as we know, part of one of the strategies to reach circular economy is related to know how much resources we have. because if we don't know the amount of resources, then our politics or our ideas to circulate the materials are going to be a bit probably out of shape, out of number, right? So we are working in a bigger team. Andre is also part of PELCAN, and it's also related to this part of the quantification of plastics. So how much plastic reaches the ocean? That's a really hard question that we are trying to understand. And to do so, we need to have more precise information. And to have more precise information, we need to develop methodologies that can at least estimate in a not that precise way the amount of plastic. So then we can make those methodologies more precise to have better numbers, because as you know, there are some reports out there that talk about the amount of plastics that reaches the ocean from rivers. And those methodologies are good, but they lack some specifics to understand other type of issues that occur for on the movement of plastics towards the ocean, especially in countries that are surrounded by ocean, like it's the case of Peru. So we know that there are a lot of different sources that can transport or can create waste that can be then transported into the ocean. For example, we have mismanaged municipal solid waste. In the case of Peru, around 40% of all our waste is mismanaged. But it's not correct to say that that 40% that is mismanaged is going to reach the ocean, right? We also have maritime activities that we are working on it. That's part of a different research that is conducted by Alejandro de Vil. We are also working in wastewater treatment plants and the amount of microplastics that reach the ocean. That's part of Andre's work as well. And we have other type of sources, like for example, tire and brake abrasions, coastal tourism, and ships, right? So the idea here, as you can see in the graph that is on the right, you can see the different types of sources and then how they move around the chain towards final disposal. And that final disposal could be adequately I forgot the name, in a landfill. Yeah. And it could also get into the soil. It could also get into rivers, like stay in the river banks, and it could also stay in the ocean, right? So the idea right now is to understand it better, because a lot of the models that we have right now, or the quantification that we have right now, are intended for the global north, and the global south have a different way, because, for example, we have a lot of the informal sector, for example, plays a huge role in the global south, right? So to have this methodology for the quantification of plastic flows, we first need to understand the situation. So we did quite a big research and a lot of field work to understand how waste is generated, disposed, manipulated. Then we need to delineate the approach of how are we going to quantify the plastics, then identify how the plastics are getting into the ocean and what type of barriers they can find, natural barriers or anthropogenic barriers, and then develop the quantification of the mismanaged plastic waste with a methodology, and then apply the methodology in different case studies. So we did a huge literature review at the beginning, then we did some field trips, as you can see, on the coastal areas of Peru. We did interviews to key stakeholders that we can that we thought they would have a good insight to give us, and we also used industrial ecology tools, like for example material flow analysis. So in our work around in our field work around the coast of Peru, we saw these images that you can see right here. For example, we can see this is a river that dries during the dry season, and you can see all the accumulation of waste on the banks. Here you can see the river that is on the north part of Peru, and how it's easy to see the mobilization of waste towards the ocean, but also we can see that there are natural barriers, like for example vegetation, that is going to stop the waste from moving. Here we can see an area in the coast, in the ocean, where we can see both. We can see two things. First, waste that is being disposed on the coast by the people that live across, or on the line of the coast. And we could also see some waste that is being moved by the river. For example, all the part that is surrounded by vegetation or these sticks that comes from river. And we could also see that there is a lot of waste that is related to fishing, because in Peru we have a huge fishing industry, and a big part of this industry is also informal. So if we work on we have an informal system there, we are going to be creating more and more waste. No? And we also went to some open dam sites in the country. For example, in the case of Peru, we have around 1,600, more than 1,600 of these open dams in the country. So we went to visit some of them just to see how waste is actually mobilized from there, and how much of this waste is recuperated, for example, how is it moving towards the ocean. So the idea here is to understand that we have the urban agglomerations, and these urban agglomerations generate mismanaged waste, and then this waste is going to enter the river basin or can be disposed on the coastlines. And then how is this waste moving? For example, we have different natural barriers like vegetation, as I mentioned, or the terrain, because if the water is disposed, for example, on a river that is going to dry during the dry season, it could be that it's going to allow for the waste to be retained there and then moved back into land by machinery, for example. And we also have anthropogenic barriers, like, for example, irrigation canals that are going to stop the waste from moving, the open dams that if they are far away from an area connected with a river system, then probably the waste is just not going to move towards the water. And we also have the dams or the hydroelectrics. In Peru, around 50% of our energy comes from hydroelectric. So a big part of those anthropogenic systems that are the hydroelectrics are going to retain waste, and that waste is going to be moved back into land, because otherwise it could damage the infrastructure, right? So we proposed this equation that is being published last year, where we have the amount of plastic, which is the PWTO, which is the plastic waste to ocean, and represents the amount of plastics that is going to reach a specific coast. And with that, what we do to calculate this is we have first we have a representation of the total mismanaged plastic waste from municipal solid waste, because we did this first for a municipal solid waste point of view, for of an urban or agglomeration that is located on a river basin. And then we remove the amount of waste that is collected by the informal waste sector, because, as I mentioned before, in Peru and in the global south, the informal sector is quite potent, it's huge. And then we divided by, for example, if the agglomeration, the urban agglomeration was in the coastline, we applied some coefficients. If it was away from the coastline, inside an interbasin between two basins, if it was close to a river basin, if the river was, the water was running all year long, or it would dry during dry season. And then we also added the effect of the barriers that were displayed along the different river basin. So for this, we developed some coefficients of waste dissipation, and we divided them by 3 categories or 3 scenarios: an upper, an average, and a lower, which means more waste reaching the coast, average, and low waste reaching the coast, for each of the factors that we saw in the previous part. And with these factors, what we did, we applied the equation for the coast of Peru. This is not published yet. We are going to publish soon. And for this, we analyzed like the amount of waste that is going to be retained per province, and the amount of plastic waste that is going to enter the ocean. So as you can see here, for example, in Tumbes, which is located in the upper part, which is an area that doesn't have any type of or the management of waste is quite low. We can see that a lot of waste enters the ocean, so the retention is low. But for example, in other areas like here, where the presence of man-made barriers is huge, we can see a higher retention. And then we estimated the amount of waste that could enter in kilograms per person per year. And we estimated that around 30 to 92,000 tons per year of plastic waste in total is going to reach the ocean from mainland in Peru. And with this, what we want to do is, and we are still working on this, we want to refine these quantifications, and we want to apply this in different contexts so we can obtain more accurate quantification of waste reaching the ocean, because that is the only way that we can actually have or implement better policies, right? If we know what is going on inland. Okay, thank you very much. And I'm sorry, I think I talked for 2 more minutes that I should have.
No, that's perfect. Thank you so much, Diana. And well, thank you all the speakers for such a great work. I think that this is going to be very interesting to discuss. Diana, if you like, you can stop sharing the screen. All right, great, thank you. Great, so let's open the panel discussion. I think that we have about 20 minutes to have a nice discussion with the speakers. So well, I would like to invite the audience, if you have any burning questions, to raise your virtual hand or using the chat box. And also, in the meantime, while you're thinking about your questions, yeah, I see that we have some. Remember that we have a small survey at the beginning of the chat. I'm going to put it again. Here is the survey. So if you can tell us, well, from where you're visiting us, it would be great. So let's start with Safdar. Safdar, I think that you were the first one. Yeah, please go ahead. Open your mic. Welcome.
Yeah, hello. You can listen me?
Yeah, we can hear you well.
Okay. Thank you for all presenters for these nice presentations. My questions to Andrea about the optimization of multi-objective optimization, like there are different indicators like economic indicators, environmental indicators. So you use any multi-objective optimization platform, or how you define your objective function in that in your study? Actually, you are muted.
Okay.
Thank you.
Nice question, and thank you for your question. Actually, we didn't do that. We actually design using the solid retention time as the main parameter. I mean, we design for the minimum solid retention times to I say to optimize the, no, it's not optimized, but it's to minimize the space of wastewater treatment plants. It might be a bias of the study, because it includes an intrinsic economic criteria, because it's the way that we currently design wastewater treatment plants around the world. But as you mentioned, it could be valuable to make a multi-objective optimization to better understand the trade-offs between economic and, I mean, it could be, for example, economic, environmental impacts. But I mean, it was a limitation of the study.
Thank you, Andrea. I think that, yeah,
all right. Thank you.
Yeah.
Thank you.
Good. I agree. I think that was very clear, and of course that happened with the research. I would like to give the floor to Alessia, my dear colleague Alessia, please.
Hi. Yes, I had a question for Pamela. How do you find the acceptance of your results in policymaking? How has that been? Yeah, how has it been received in general?
Well, we evaluate in general the process of the development of the material flow analysis. One of the researchers was actually one of the third party actors in the involvement of the process. So we did like an abductive research in that way of observing the different development of the strategy. However, one part of the research and why now is not published yet and we are finalizing is a round of interviews to validating the results and to see also how in time it has evolved in the implementation. Hopefully, I hope it answers your question.
Yes, and if I may, I also have a question for Diana. If anyone else has a question, please feel free to interrupt me. But I think it's really cool. I don't think I've ever seen a research done in that kind of manner in this kind of country. So I'm really interested to see once it's published how it's done. But I'm more wondering about what are your next steps with this kind of results? Now that you know this information, what are you planning to research?
Thank you. That's a good question. Actually, the equation is already published, but we used only a case study in the north part of Peru. We didn't use the whole coast because of time. And the one that is going to be for the whole coast that we are actually publishing soon. We already used the equation for another study in Ecuador. That one was also the idea of this part. And we are also interested in understanding how waste is moving in the jungle, because there is a huge difference between the rivers that move, that go from the to the Pacific.
Oh, we're having a small delay there. Yeah, let's see if we can recover Diana, because that was a very interesting question and answer, of course. You can hear me well, right? Yeah, okay, good. Yeah, I see some nothing.
I'm sorry.
Yeah, Diana, we missed you for a bit, so maybe if you can repeat the last part that...
Okay, sorry, the Wi-Fi in PUCP sometimes it's not that stable.
It's fine, that's the beauty of Latin America.
Yeah, instability, that's our thing. We are going to try to do the same assessment in the jungle. So we want to see how waste is moving in the rivers in the jungle part, because those are bigger, they have more water, they move slower. So we think that the dynamics are going to be different there. And we also want to improve the numbers that we used. What's the name of for the equation, because we do think that we could refine them more, so to have more precise numbers now. And also we are trying to expand the use of the equation. We did it in Ecuador. I don't know if that part was heard. And we are trying to find other countries that we can apply it so that we use it more.
Great, thank you. Can't wait to see what the results bring. It's really interesting.
Yeah.
All right. Thank you, Alessia, for such a nice questions as well. And of course, the answers from Diana and Pamela. I just realized that we're having some issues in the chat, but then, and thank you, Paul, for letting us know. But then what I would suggest is just everyone that is right now in the room, that we're quite a few, just answer the question that I just posted right now. Basically, we just want to know where are you from where you are joining us today. All right, let me bring one more question, because I think it's very interesting, the journey that we took, right? We start from the policy side, also going into more industrial level, into the fate of our materials in society with those nice pictures that Diana showed. In all these levels, I noticed that there are some challenges in terms of data. And I just want to ask you right now, in terms of advancing in this kind of assessments, what are the key challenges that you notice in terms of the data that you are using? So Yeah, maybe we can start with from the top with Pamela, and then going down again from Andrea and Diana. So what do you think that are the most challenging parts in terms of data collection?
Yeah, from my side, one of the main challenges we found, we have worked in metabolism analysis for various countries across Latin America, and accessing data, different data systems, different actors that manage those data systems. We found the data in, to say it in a way, in fully completely languages, different languages across the same country. And of course, data that is not actualized. We found data from 2004, 2015. I'm talking specifically right now. I'm talking in the case of Panama, case of Colombia, case of Uruguay. I think that's one of the main challenges we have found at this national level.
Thank you, Pamela. Andre, do you have any thoughts on this one? Pretty sure that yes.
Well, in my case, regarding wastewater treatment, and the main problem is try to characterize wastewater composition, and well, the information in Peru is not always available. In our case, we have access to some reports, and we can characterize the wastewater composition of wastewater of Lima. However, to make a better analysis, it would be valuable to know a dynamic composition of wastewater that is available, for example, in some countries in Europe or some countries in the global north. But here, the data is limited, so we have to make some approximation to the reality. But at the end, I think that the analysis was represent mainly the reality, because we have some proxy data.
Perfect. Thank you, Andre. Diana, we would like to hear your thoughts now.
Yeah, we actually, as Andrea and I are from the same country, we have quite of the same problems, I would say. But I can add that, for example, one of the things that are like a huge challenge in terms of getting useful information is the fact that the country is really informal. So a lot of, for example, the collection of waste, or a lot of the how waste is treated and how is it going from the collection to the back to the system into companies, that part is missing because it's informal. So it's really hard to know the actual amount of waste that is recuperated, for example, and it's really hard to know even how is it mobilized, like where is it going from where is it moving? Is it, like, for example, we do have some information that comes from municipalities, but that only happens in the big cities. So, for example, Lima or I don't know, Arequipa. So those big cities do have a lot of information that we can see is reliable. But if we go to smaller cities, like rural areas, for example, then the information is really, or that just doesn't exist, or it's really hard to grab information that you would say, okay, this is reliable and I can use it.
Great, thank you so much, Diana. Well, there are about 5 minutes to go, and yeah, let's see if there is any other burning question. Otherwise, I would like to bring one more just to finish in the high end. Well, I want to thank you again. This has been very inspiring, and in that sense, I also want to hear from your perspective. Considering the research that you have shown us, I think that this can be very inspiring for other regions in the global south. So maybe you can tell us, how do you see this inspiration moving forward? I mean, what lessons from the research that you have presented us you think that can be also useful for other regions in the global south? And maybe we can start in the other way around. So I would like to ask Diana.
Yeah.
And maybe just keep it short just to finalize with.
Yeah. I can keep it short. I think that our work highlighted how, again, informality is so important. So I do think that after what we saw and after what our conclusions showing that we do need to improve how information is recollected, and we need to improve how the informal sector is connected with the formal sector in a more easy way to do it. That's the only way that we can do to move forward, especially in circular economy, because if most of our economy relies on informality, then how can we know the amount of resources that we can mobilize to different options, right? So I think that the fact that we are trying to solve one of these issues, which is plastic waste, is going to be a way of showing how we can do it for other type of materials as well.
Thank you, Diana. That's very insightful. Andre, you have some thoughts? You are muted.
Okay.
Yeah.
Well,
great.
Thank you for your question. Well, I believe our research can inspire other regions of the global south by demonstrating how to turn challenges into opportunities. For instance, the region's pressing issues such as water scarcity and inadequate wastewater infrastructure and wastewater treatment plant, for example, push us to innovate with context-specific solution that integrates circular economy approach from the outset. These solutions showcase how emerging economies can bypass traditional approaches and develop a system tailored to their specific needs. I mean, this adaptive strategy can serve as a guide for other regions of the global south to face similar challenges.
Great, thank you, Andre. Thank you for your final thoughts. This is very inspiring. Well, Pamela, what can you tell us?
Yeah, from my perspective, in the region, such a fragmented institutional framework in the region, from our research, we can draw some insights on how public governance can use tools, management tools such as MFA, but not only use the tools, but the way to use the tools, that participatory process in implementing these tools for that priority setting could be is that first step to setting that common goal as a public sphere. I think that would be my thoughts.
Perfect, great. Thank you, Pamela. Well, now I think that with this very nice insight from our speakers, I think that we're at the end of our session now. So yeah, I want to thank you all for being here. Oh, wait. Now that we have 1 minute, I want to take the opportunity to see if we can take a nice picture of the whole room. So for those ones in the audience that you feel comfortable with, I would like to invite you just to turn on your cameras. And well, we can have a final picture of this nice session. Thank you, Paul. I think that we are the only ones. Awesome. All right, so I will make a count here and let you know, just to put a nice smile. Let me see. No, I don't have it yet. Just give me a sec. I think we're giving some time for other people to join the picture. All right, ready, everyone? 1, 2, 3. Awesome. Let me see. Good. Well, thank you so much. I want to close the session here, but I see that Paul, you raised your hand. I don't know if you have anything to add or.
Yes, sorry, I'll do it very quickly. I just want to thank everybody for this session, and also want to say that I think South-South collaborations are very useful, and we should explore that more. And I just want to extend an invitation to all the presenters here and all the people in the audience that I'm based in South Africa, and if you need any contact here to try and explore collaborations, I'm very happy to connect people with my network here. So just to extend that invitation. Thank you very much.
Oh, that's lovely, Paul. I think that this finishing a high note as well for further collaboration. But anyway, let's close it here. Well, thank you all for joining us today.
Thank you.
Bye-bye.
Bye.
Thank you.
Bye.
Stop the recording.